Now, there's one of the effects of wave due to some effects is what? Stationary or standing wave. Or standing wave. Now, this occurs when two waves with the same amplitude, wavelength, or frequency meet. This occurs when two waves with the same amplitude, frequency, amplitude, wavelength, the same amplitude, frequency, wavelength meet. With the same meets when moving in opposite direction to each other. Opposite direction to each other. Direction to each other. To each other. Now, let me show you a live example of what I mean. Now, for instance, you strike a string, let's say a guitar string, you know one edge is attached to this place, and another edge is attached to this place. So let me just do a line, straight line. Then when you strike this string, then you see a movement like this. It goes this way. Then stop it. But now there's now a rebound movement. Are we together? Because this occurs when two opposite waves, that is two waves moving in opposite direction with the same frequency and wavelength meets. So for instance, let's say this occurs when two waves. This occurs, I've said a string. Look at the string, I'm using it as point of illustration. So now you try this string, it moves like this. But when it hits this place, it will what? Reflect. And then it moves in opposite direction with the same amplitude and frequency and wavelength. That's why it's what? Intersecting here. Look at it. To move it, to move back. This will continue happening till when it will come to what? Rest. And this kind of forward and backward movement of the wave, whereby they meet at this point, whereby the amplitude, frequency, and wavelength is what? The same. It is called stationary wave. Now, these are the effects. So it's called what? Stationary wave. And this stationary wave only happens with what? Transverse wave. And then in this stationary wave, this point is called your node. 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 And this middle point, the middle here, from this place to this place, the middle here is called your antinode. The middle here is called your antinode. And the middle here is called your what? Antinode. The middle here is called your antinode. The middle here is called your antinode. So, the middle here is called your antinode. The middle here is called your antinode. So now take note, your node is where there is no movement. Now look at this place, where they intersect, there is no what? Upward or downward movement of the wave. So this place where there is no movement is called your what? This point I call your what? Node. This place is called your node. And the middle is what? Called your what? Look at the middle. The middle is called the what? Antinode. Please take note of this. Now, the next thing I will be discussing with you guys is properties of wave. Properties of wave. Properties of wave. Now, we have some properties of wave, which is like reflection. So now, when a wave is moving and it hits an obstacle and moves in opposite direction, we call this kind of occurrence reflection. So when a wave hits an obstacle, so reflection is when a wave hits an obstacle and move in what? Move in opposite direction. Now, diffraction. Diffraction is when a wave hits an obstacle and bends around that obstacle. Diffraction is when a wave hits an obstacle and bend around the obstacle. While we have refraction, reflection, diffraction, pause. Refraction is when a wave moves in two different medium with different density, and then when moving from one medium to another medium, the direction will what? Change. That's what refraction is. So refraction occurs when moving in two media of different density, and in which it changes its direction. It changes its direction. Now, there are some formula associated with what? Refraction. So the formula is, we have refractive index, which is what? N represents what? Refractive index. Now, let's say the medium is moving from what? The two medium is air and glass. So the refractive index of air and glass. So this A means air, this G means what? Glass. So this N is refractive index of air and glass. So now the incident angle is the angle where the wave inclines the glass is what we call the incidence angle. So the formula is sin I over, and where the wave passes through at the back of the angle is called the refracted angle. So sin R, and that wave will change direction when it passes through the back of the glass. So this is the formula sin I over R. Now there is something that changes why the wave is moving through the glass, moving from air to what? The glass medium. There's something that changes. The velocity changes. So therefore this formula is just equals to V1 over V2. And then the wavelength changes. Therefore we have 1 over 2. So take note of these formulas. Very, very important. But the frequency does not change. So these are the properties of